Okay, so these are more complicated, but they're still linear equations. So what I want to do on this one, the first thing I want to do on this multi-step linear equation is I want to distribute the negative. So this negative here is just like having a negative 1 out here multiplied by these terms. So if I take negative 1 times negative 3a, that will give me positive 3a. And then if I take negative 1 times negative 8, that will give me positive 8. And then the next thing I want to do, if you'll notice here, you've got a number here 2 and a number here 8. And we know 2 plus 8 is 10, so we can add those together. And that way I'll just get 10 plus 3a on the left. And now I can do what I did in the previous video to get the 3a isolated. I'm going to subtract 10 from both sides. So if I take 10 away from the left, then 10 minus 10 will cancel. And then if I take 10 away from the right, I'll get 1 minus 10. So now I'll bring down the 3a, and then I know 1 minus 10 is negative 9. And then to solve this for a, just divide both sides by 3, because I know if I divide 3a by 3, then the 3 over 3 is 1. And so that's just going to give me 1 times a, which is a. And then here, negative 9 divided by 3 is negative 3. So my final answer here for this equation is negative 3. Now the next two are a little more complicated, but basically we're doing the same thing. Here we've got a negative in front of this parentheses, so I'll just distribute negative 1 through here. So when I multiply negative 1 times negative p, that'll give me a positive p. And then negative 1 times 1 is a negative 1. But then over here I have a 2 that has to be distributed through these two terms. So I'll say 2 times 6 is 12, and then 2 times 8 is 16p. And then I'm going to collect the like terms on the right. So on the right here, you'll notice I have 1p. Remember, this is like 1p. So 1p plus 16p gives me 17p. And then here I have minus 1 plus 12, which is 11. So I'll get 11 there. And now I can isolate my p. Now, you don't have to isolate your variables to the left. You can actually get your variables isolated to the right. So I'm going to leave the 17p over here. And I'm just going to subtract 11 from these terms over here, so that when I subtract 11, it will cancel the 11, the plus 11, and then I'll just have 17p by itself. Now if I subtract 11 from this side, I also must subtract 11 from this side, so I have negative 57 minus 11, and that's going to give me negative 68. So now I have negative 68 equals 17p, and so now to isolate the p, I can divide both sides by 17. So if I divide 17p by 17, that'll just give me 1p, which is p. And then if you divide negative 68 by 17, negative divided by positive is negative. So you'll get, and 17 goes into 68 4 times, so you'll get negative 4. And my answer is negative 4 equals p, but I can also write that as p equals negative 4. Now on this last one here, you'll see I need to distribute on the left here the negative 6 through these two terms, and on the right the negative 8 through these two terms. So let's start over here. Negative 6 times 8k would be negative 48k, and negative 6 times 4 would be negative 24. And then on the right hand side, negative 8 times 6k would be negative 48k, negative 8 times 3 would be negative 24, and then just bring down this negative 2. Now I don't have anything here that'll combine on this side, but on this side I have negative 24 minus 2 I can write as negative 6. Now what I'm going to do first is I'm going to add 24 to both sides, so I can, that way I'll get my all my numbers on the right. So if I add 24 to both sides, that's so that it'll cancel this negative 24, because if you take negative 24 and add 24, it cancels. And then on the right side of the equal sign, if you add 24 to negative 26, negative 26 plus 24 is going to give me negative 2. But now I still have on this side, I still have the negative 48k, so I'll bring it down. And I also have a negative 48k on this side, so I'll bring it down. Now, so what we're going to have to do here to get the negatives, to get the all the k's on the left, is I'm going to have to add 48k to both sides. But when I do, something strange is going to happen here, so watch and see what happens. When you add 48k to this side, the minus 48k plus 48k gives me 0. And then when I add 48k here to this side, the negative 48k plus 48k gives me 0 there as well, but I still have a minus 2, so I end up with 0 equals negative 2. Now, that's actually a statement that cannot be true, so that's a false statement. Since 0 can't equal negative 2, then I have to assume that this problem has no solution. Now, on the other hand, had I gotten a statement that's always true, like 0 equals 0, then this is a problem that would have infinitely many solutions, because it would then be an identity. So this is a false statement, but if you had gotten 0 equals 0, then you would have had an identity, which is true for every value of k. So this problem has no solutions though. So that's how you solve steps with 3 or more, or problems that have 3 or more steps in them on these linear equations.